The scene I currently have opened is compatible with View 9 and up, and it's provided with training called Rocky Landscape. Just a really simple scene or a simple terrain setup with a baked elevation as well as color on the terrain with a little bit of an ecosystem. The ecosystem is only two vegetation species, but it'll help us evaluate the lighting of the scene because terrains and what the atmosphere looks like and vegetation along with other objects are all going to be lit differently depending on the materials and the different gamma settings. So first, taking a look at the gamma, if we double click on the main camera, current display gamma, I have mine at 1.4. The texture map input I have set to 2.2, which is going to create a darker map overall. And then the output gamma is 1.4, basically just saving the images as they appear. So I've got the camera lifted up right now, showing a good portion of the terrain. And this is what it looks like when rendered out. Not a whole lot of detail on the terrain because it's actually being created by an image and basically a rendered out function. So that way that calculation doesn't have to be performed and we can look at the atmospherics much quicker and see a better result. The scene currently has just the default atmosphere loaded in. The aerial perspective is set to 1. So the density that we see from the atmosphere is going to be mostly realistic to the scene scale. They're pretty well matched up. I'm going to go ahead and load in a preset atmosphere that comes with View, and from there we're going to customize it and get it to fit this current scene and then modify some of the settings that are in there and really make it look a little better. So I'm going to go up to Atmosphere, Load Atmosphere, and we can pick from, the best ones to pick from, of course, are the spectral atmospheres. The clouds are going to look the best. And just the overall lighting and everything else will look much better. And I want to go over to the bad weather, where we have kind of a mix of the different spectral versions. But I want to pick something a little darker to start with. And let's pick the Dark Storm. And it says GR on it, and that means it's using global radiosity. We're actually going to be turning that off for the moment. And we do need to make quite a few customizations before this is really going to look good, because I do believe this one is using the Spectral 1 model. To begin with, it is pretty washed out if we look at the preview. We're going to go to the Atmosphere Editor and kind of take a look at what's making up the scene. We have a lot of fog, which is taking away a lot of the light. And this is definitely one of the older presets prior to the new unit system in View. So it is using an aerial perspective of 10 rather than 1 because the internal unit or the View unit under File Options, units and coordinates used to be 0.1 and now it's 1. So the conversion will change the aerial perspective. So we should see a lot more going on in the scene. At least be able to see a bit further. The haze is set really high, so I'm going to go ahead and bump that down. and the sky does not look like it is really updating. I think that might be because of the dynamic population. For the moment, I'm going to remove the ecosystem. We'll bring it back when we need to adjust maybe texture maps and just the coloration, toning, in order to get everything to match up correctly. And so that way you don't have something that only works for terrain, and then when you put an ecosystem in, it just doesn't look right. So for now, I'm going to just turn off dynamic population, double-clicking on the material preview in the upper right just to open this window. By turning off dynamic population, it'll remove the preview, and then there's nothing populated. So we might be able to get the sky to refresh. It looks like maybe I'm in the wrong shader mode. I'm going to go to File Options, and I do need to switch over to Shader 4 really quick, which is going to require a restart. So now the atmosphere is updating properly. So that way we can get a good idea of what it looks like just in the OpenGL without having to look at the render preview, which I'll go ahead and make a little bigger. Taking a look at the cumulus, now these cloud objects, what we have is a box that represents the position and size of the object, also the rotation. And this object itself can be used, of course, to scale and position the clouds. Also, whether or not you want to turn a cloud layer on or off by clicking on its icon to hide it from the render. This object itself does not save your cloud layer. If you've edited a cloud, modified the materials, and then you wanted to save that, right-click Save Object is not going to do any good. What you need to do is go into the Atmosphere Editor, and under Clouds, we have this cumulus. Go to the lower right and save out. Actually, that will save the material. And if you right-click within the preview of the cloud itself, you can save the material, which will save the cloud layer, and it will also save the altitude, height, cover, density, and all this additional information that's available with it. So if we go to edit this object, what we're going to see is if we go to the Lighting and Effects tab, our lighting model is set to volumetric layer, or version 1, which is the old spectral model. Spectral 2 looks much better. What I'm going to do is switch to Spectral 2, or the volumetric layer version 2, turn on Cast Shadows, GI Ambient Lighting, and then go over to the color and density, and I'm going to right click on the filter and reset the function as well. Now what I want to do for this cloud layer is work with the roughness. The roughness setting is the internal function or the detail that creates the cloud shapes and subtracts from any function that you have. So right now, without there being any density production, we're going to see just that internal fractal, which is controlled by the detail amount. So if I remove the detail, it's basically going to render just a flat cloud, depending on the cover amount. Now, because I switch it over to Spectral 2, I want to add a bit of sharpness to it, and maybe add just some feathering. But I'm going to crank up the detail amount to start to 100%, and then take the scale of the material and bring it down to 0.5. Now the altitude is a little high. I'm going to go ahead and go into the front view, and then we can use the gizmos for move and scale. Move, bring it down. Scale, we can squish it on the z-axis to adjust the height, which may not update. The atmosphere editor probably won't update real time. You'll need to close it out, open it back up. So click OK, F4, open it, and then it's going to give us their height. And I'm going to reduce that and just type in a value of 500 meters. And we can see that cloud layer. So this is just that detail layer. Now the advantage of using just the detail is that no additional functions are added, which will decrease render time. And we do have quite a few options we can change to adjust the detail or the internal detail layer. So a lot of times you don't even need to have any sort of density function. One thing I want to do is go to the density slider and increase that to 100%. We would see the clouds a little bit better. Take the opacity amount, bring it up a little bit. Decrease sharpness. And if you want to take a look, what we're going to see now are some of the options we can use to modify that detail. So if I go to edit the material, right click, edit material, the cloud layer detail that we see showing up in the color and density tab, these are the controls for modifying that internal cloud fractal. And what we have, scaling, which is going to be the overall cloud scaling, what size we want the separations to be, mainly overall. So how big do we want the clouds? And then the roughness value is how distorted we want them around the edges. So no roughness, you might not even see clouds. Looks like little puffs are showing up. 100%, it might fill in everything. Once you get too high of a roughness value, it will pretty much cover up the whole sky. I'm going to reduce variations a little bit. Uniformity is the basically cutting out and smoothing the bottom of the cloud layer. So whether or not you want to have a flat cloud or flat cloud bottom, or you want to have it to be curved to match the rest of the cloud. So if it's 100% uniform, then we should see more of the overall shape of the roughness. Turn that down, it should smooth it out. So just add a little bit of that. Now to get the most control out of the shape of really any cloud layer, what we have is a cloud layer profile. Now right now it's set to a custom cloud layer profile, and it's basically just a filter. If we edit the filter, you take a look, and what this represents is on the left side, that's the bottom of the cloud layer, the lowest point of altitude. So basically what would be the bottom, what we could see are cloud object, and then the top of the filter is the top most part of the altitude. The in-between portions represent the outer density and how we can cut away from that edge. And this is a cloud I created in a different, shown in a different training product. But it's a good representation of what you could do with a filter. And in this case, we can see it flattening out of the bottom. And this is just the cloud itself was basically a sphere to begin with, being cut out in the layer. And then adjusting that filter, able to make the curvature around the edge. And then it's an even subtraction throughout the density around the edges. So it gives you a little better idea. It'd probably be a little easier to work with if we could rotate around this filter, but we are kind of fixed with it horizontally, although it would be a little easier to understand if it was vertical. So just kind of think of it as a vertical filter. So if we turn that off, we're going to see a different cloud shape. We can really modify the density with that filter. We could load in filters, turn that back on, double click, and you can load in filters that come with the program. There's a lot of filters for different things. It doesn't look like there's any specific cloud filters in here. One thing to keep in mind is when you're making the filter, you don't always have to follow this, but it is a good idea to start and end at -1, which is the bottom portion of the filter, so starting down at the bottom, and then also when you end the top there, because otherwise you're going to create too much fill within the sky, and it could cause a bit of graininess in the render. So going back, if we reduce roughness a little bit, we can see it also decreases the cover amount. And a lot of these settings will have a big impact on each other. Click OK, and I'm going to reduce the cover amount. So this way we could reduce the overall fill throughout the sky. And bring it up to 50. And then just take the density, bring it down to 80, opacity to 60, and then we'll take a look at a render. Now I did still have the radiosity turned on, and I am going to turn that off because for the most part the material is really not set up for it. I did render out a color map for this terrain in order to just get render faster, but it doesn't look very good with radiosity lighting. So I'm going to go to the light tab, switch it over to global ambience. That should be good for now. Very bright scene right now. Also, the light balance, I'm going to go ahead and move to about 30% and then match the ambient light. That way we can still get some shadows in there. Going over to the Sky Fog and Haze tab, maybe reduce our haze a little bit, and then if we start reducing the fog density, we can get a lot more contrast to show. Reduce our glow intensity a little bit. A little too bright. And then go to back to the cloud layer, and I'm going to show you something else you can do. You can go over a lot of these values. You're not just stuck at whatever the slider is maxed out at. So the detail amount's at 100%. We can increase that, let's say 300%. And what we're going to get is a much more defined outer edge for the cloud layer. And you can get some really neat cloud formations this way. I am going to reduce the height because the cloud layer I think is a little too high. So we'll do 250 meters. Take the density, let's go ahead and do 60. Because you do need to balance between the density output and the detail amount if you're going over 100% for the detail amount. Might even need to decrease the roughness because even a minimal amount of roughness, if the detail amount is really cranked up very high, you're going to get very tiny little bits of the cloud sticking out that are going to look really grainy. So now when we take a look, with that detail amount really turned up very high, you end up with much darker areas underneath the clouds and around the edges where basically that internal fractal starts to fold in on itself. And the density becomes higher in those portions and can make some really neat looking cloud shapes. If we wanted to thin those out a bit, we could go over to our detail, and we can still turn it down. So even though we don't have the density production from a fractal, that internal one works really well by itself, even if detail amount is almost or close to 0. The closer we get, the more it's going to use the density production, which is just empty right now. So that'll do a full fill on the sky. So just reducing the density, increasing the opacity amount, maybe decrease sharpness. And decrease ambient lighting just a little bit. And maybe bring down our altitude. Let's create some lower clouds so we can see them up close. And of course, you can always fly through them as well. You're not restricted to being above or below. They are 100% volumetric, so you can do quite a bit with them. I'm going to decrease the size of the material, which also decreases the size of that internal detail layer, as well as any density functions that are created. Now, this render took more than twice as long as the last one, and the reason for that, the less density you have in a cloud layer, and if it has a lot of volume, the more light calculations need to be made because more of the object is transparent or opaque. In different ways than it was before. So more light calculation, longer render times. One thing to keep in mind, if I actually increase that density to a much higher amount, the render time will significantly decrease. So for this, if I wanted to make it look a little better, go to our scaling, probably modify that a bit, and using the scaling together with the full material scale, adjusting the cover amount. Now we could have more of a complete overcast. Depending on how the height is set, it'll move between the different areas of the volume. And you won't always have clouds that are going to be right on top of each other. You start to fill in areas throughout the scene and just throughout the volume in general. And they will be kind of patchy in different areas and not always at the same altitude because it is a complete volume. So if I was to take our height and really bring it up very high, we have lots of patchy clouds all at different altitudes within the 10 kilometers that's available. And they're more than likely not all really lined up. So by reducing the cover and the height, I should be able to get just small little patches of clouds. We'll go ahead and take a look at that really quick. And then I want to show you some different things we could do with God rays and volumetric lighting, and also the ways that the shadows work between the clouds. So there we can see those nice low clouds. Lots of little patches here and there. I'm going to go ahead and save a version of the scene out at this point, and then we're going to take a look at the different atmospherics. I'm going to go ahead and save the camera and restore the camera, which is going to be camera 3 in the current position. And in order to see this better, I'm going to go ahead and zoom in, adjusting the focal so that we can see more of the distant part of the terrain, start to see more of the atmosphere. For now, I'm going to turn off the cumulus clouds and that cloud layer. Go to the atmosphere editor, sky fog and haze tab, and add a little bit of a decay. Adjust that fog a bit, and add some glow. And I might even need to raise the elevation of the terrain. So I'm going to select the terrain and scale it on the Z to raise it up. And this way we're going to be able to see a lot more what's going on with the light. In order to block it, we need some better shadows. So I'm going to, in the atmosphere editor, sun tab, reduce the pitch. And that way we get some longer shadows that can be blocked. Looks like I need to go back to the light tab. Let's bring our light balance to 50%. let's just take a look at it right now before any additional changes are made. So at the moment, the atmosphere is being evenly lit throughout the scene. The terrain and its position is having no impact, so even though there are shadows coming from the terrain, they're not darkening the atmosphere and creating rays. So what we need for that is a volumetric sunlight in order to get that effect from a terrain. So if we go to the atmosphere editor, and also I'm going to go ahead and actually I meant to do the sunlight. Open the sunlight, go to the shadows tab, and just make sure the shadows are set to 100%. And using ray tracing as well. Go to the sky, fog, and haze tab, and now the options on the bottom of this pull-down menu, it can be a little confusing because the main option by default is no shadows on clouds. But with volumetric sunlight, it doesn't necessarily have to do anything with clouds, so it can be a little confusing. Projected shadows on clouds refers to objects casting their shadows onto cloud layers and other cloud layers casting their shadows onto other cloud layers. So between clouds, and then terrains onto or objects onto the clouds. Clouds automatically will cast shadows onto terrains or any other objects in the scene, and we'll take a look at that in a minute here. But first I want to do is turn on the volumetric sunlight option, and you got to really kind of set this up in order to be able to really see it a little bit better. So what we need to have a little more atmosphere. The easiest way to do that at this point is just to increase the aerial perspective. And then a lot of it has to do with where my light position is. I can start to see the changes, but I'm going to go to the sun tab, and I'm going to just knock down the pitch of the sun even more, and then adjust the azimuth, change the angle a little bit. And I did just reposition the sun to be just over those hills in the back, and casting light only really on the peaks. If we go to the sky, fog, and haze tab, now I do have the volumetric sunlight turned off, and I just want to show you really the difference between the different atmospheres. Is a really big difference. So first we'll just take a look at this without the volumetric sunlight, because this is a much better example. You'll really be able to see the way it works. Okay, so we see a lot of the haze and the fog, and just the overall atmosphere being lit pretty evenly. So now I'm going to turn on the volumetric sunlight, and we can take a look. So at the moment the effect isn't extremely intense. There are ways to get it to be more impactful, but we can see, you should be able to see lines starting to show up on the edges. I think it's our ambient lighting is just way too high. There's probably too much haze or fog. Compared to the other render though, you don't really see the coloration, so you can tell that it's getting darker, but I do need to make some more modifications in order to get this to work. So what I'm going to do is pick up the sky mean altitude, go over to the light tab, maybe increase a little more towards sunlight, go to that sky dome lighting gain and -0.1. Glow intensity is a huge factor with God rays and volumetric light. And looks like that might be a little bit too bright. So we'll go ahead and bring back the decay, maybe just drop it down so that the light intensity is a little higher. So reduce the haze altitude and density. We can see things a little better. I'm going to switch over to the view position gizmo and move the sunlight, making sure point at camera is turned on, and move it just behind those peaks. And we should see it coming through with a light ray, as opposed to the setting with it turned off, where we have this extremely illuminated haze and fog overall atmosphere. So with volumetric sunlight, there's a big difference there, and I'll go ahead and render that out. Now, the reason why this is typically off and not always used is because the amount of render time it will add. Also, depending on lighting situations, it can be a bit grainy. God rays tends to be a lot more grainy. Although if you're using volumetric sunlight, there's typically no need to use God rays, because that's basically already creating those effects. So now we can see that a lot better, the different beams coming in. It's really just a matter of adjusting the intensity of some of the different atmosphere settings, reducing the fog and haze a little bit. Maybe even picking the camera up a little more. Because a lot of times you won't see the way the volumetric works unless you're inside of a shadow. So it really depends on a couple of different setups. If we go ahead and render just that area where the sun's just peeking through now from this angle, there's now that very defined ray shadow within the light. So I'm going to right click and discard the render area, add in a new cloud layer, and go ahead and select the thick high cumulus, reduce the height, and the only way that you're going to get rays through clouds is if the cloud has the ability to project shadows or cast shadows. So what I'm going to do is take that density and bring it down to 200. Click OK. Select the sunlight and just move it up. Overall, the scene has gotten very bright. I'm going to go to the atmosphere editor and make a few adjustments. Aerial perspective, let's go ahead and bring that back down to 1. Glow intensity, we can reduce that. That'll help a lot. And provided that the cloud layer has cast shadows turned on, we can start to see with the volumetric sunlight on that clouds will have light beams going through them, really depending on a couple of different factors. So kind of go through those. The thick high cumulus, what we're going to do is increase the density of the shadow. Actually, I will bring up the regular density to 300 and bring up the opacity a bit. The denser the cloud, the more likely it is to cast a shadow and create a light beam. We can already start to see some light beam showing up. So what I'm going to do is just go ahead and I think render that out. It looks pretty good where the sun's at right now. The trick is really to just kind of get the sun behind a cloud or just on the edge of a cloud, and then adjust the camera slightly, pick it up or down, in order to really be able to see the depth of the light beam. And because volumetric sunlight is turned on, God rays is not needed. It's already producing the effect we need. They can be used together, but sometimes the results just aren't desirable in some cases. I'm just going to try to get a little more contrast in the sky. Go ahead and render that. And actually, this is still rendering. I'm going to stop it because there's one thing I wanted to turn on, and I forgot. Right-click on the little camera up there to get the render options open, and I'm going to turn on or check off Enable Relighting, which will allow us to adjust the light after the render is completed. So I'm going to go ahead and re-render with relighting active. So now if we take a look in the post-render options, we can see the relighting option for the sunlight. Any light that's going to be in the scene is going to have a slider, intensity, and color. So you can even change color after the render with relighting. Overall, it looks alright. Would probably need to increase the quality boost in order to get rid of some of the graininess. It's not too bad. I've seen much worse. What I'm going to do is change the gamma down to 1 so that we can see the beams a little bit better. The typical gamma for view is 1, but things, the more recent changes, and I believe the default set to like 1.6 or 1.8, so it's kind of a big difference from 1. And those contrasts and just that overall balance in light has affected a lot of the way the quality boosts perform and how things have been adjusted on Eon's side in order to get it to look good. But if we adjust this slider now in the post-render options, we can see, so if we start from a very small amount and increase it up, we can have the light beams coming up. That's pretty neat. We can also increase the intensity. So if I want to decrease exposure and increase the sunlight, get something pretty interesting that way. So if we want to have a very high contrast look, we can do that. So you can go really high with it. Another cool thing is you can even go into the negatives. Looks like maybe that's not going to work too well right now because we don't have additional lights in the scene. If there were additional lights, then we would see a subtractive value. But a cool thing is not only can we adjust the intensity, but we can also adjust the color. So right-click, edit color, and then we can, let's go ahead and pick kind of a yellow light. Now everything has a yellow lighting on it. We could switch it over and make it blue. So there's really a lot you can do with relighting. So instead of spending a bunch of time rendering different changes, you can just make these changes in post. One thing I like to do is set up multiple sunlights in a scene, render it with relighting, and then you can use different sun positions and just render it all out at once, and then decide which one you want in the end. So that's pretty cool. So that these changes aren't applied to the scene, because what will happen is the intensity values and colors typically carry over. I'm going to reset the color. I'm going to bring my gamma back. Click OK. And there's just one last thing I want to show you, which has to do with uh, the way the clouds react when within a terrain area or an object area. For now, I'm going to go ahead and turn off the current cloud layer and just kind of take a look at the lighting. I think because we have all these different parts of the scene affecting the overall lighting, I'm going to go ahead and load in a different atmosphere. Maybe go back to the default. So from Spectral Sunshine, the first preset is the default. Looks like maybe that loaded the aero perspective of 10. I'll bring that down to 1. And now I'm going to add a cloud layer and select, let's use the dense stratus. And we have those at 100 meters. And then the height's 100 meters. And I'm going to take the density and bring it down to 100. And then also increase the material scale a bit. And we're going to edit the material and adjust the scaling option. And we can use the object to kind of place things a little more accurately. And maybe I do need to reduce that scale. I'm going to reset the function for the density production. And get rid of the altitude variations, which typically I think are too high. And reduce that detail amount, increase opacity, decrease the cover a little bit. And these are really light, so I'm going to turn down the ambient lighting, increase the shadow density. And we'll just go ahead and move the camera to having it look down so that we can see onto the clouds. And let's go ahead and I'm going to change it so that we have the light set up so that the terrain will be casting shadows onto the clouds. So going to the sunlight and reducing the pitch. Now, we're not really seeing any shadows showing on the clouds at all. The terrains just are not casting onto them. And if we had another cloud layer in here, we wouldn't see any sort of cloud interaction between shadows being cast from one layer to another. And of course we can mix layers. You do have the ability to do that. You're not restricted to having layers at specific altitudes. They won't cut each other out. They'll just mix and blend together. But if we want to get all the shadows matching, there's two ways. We can either go back to the volumetric sunlight, or the faster method, if you don't need to cut out the atmospheric, and you just need to project shadows onto the clouds, then use the project shadows on clouds option. You won't get the rays that you would normally get and the cutouts from the actual sunlight. The atmosphere itself will still be lit, but the clouds will have proper shadows on them. And projected shadows on clouds renders much quicker than, of course, the volumetric sunlight. So go ahead and just take a look at a render of this. And those clouds look like they need maybe a little adjustment. But for the most part, they look alright. So the shadows are showing up really nice. And with a more increase on the lighting, you can see a little more depth in the cloud layer. It's really choppy right now. the size is just way off. So what I want to do is go into material and cut down the uniformity, decrease that roughness setting, really bring that down a little more. Maybe increase scale, and might have to decrease the scale. It looks a lot better. Increase the detail amount, add a little bit of feathering, decrease the sharpness, increase cover. And that should fill in much better now. A much flatter layer. So I'll just go ahead and render that really quick. You can take a look at something a little bit smoother. And if we wanted this to become more of a low fog, what you can do is just decrease the density to a lower amount. And that tends to work pretty well. You might have to use decimal values, but it can work. It looks a little better now. It's not so grainy, but not really quite as smooth as what I had in mind. So maybe decrease the detail amount and increase the scale just a little bit. 0.3 for the material scale. And that has made a very large difference. So it's really smooth. And this is just a rendered area of the lower portion, just so you can see that smoothing on the clouds. Going back to the cloud layer material, if we go over to the lighting and effects, there's one last thing I want to show you, which is the dissolve near objects. In case you didn't know it was there, it gives you the ability to set a distance amount from the surface and how far away the clouds dissolve. So this is based on object relation to cloud layers. And you can do some really cool effects with this. More so when you're combining different layers and kind of cutting things out. But this way, if you want to have a bit of a decay or just a separation between the terrain or any object and the clouds, you can set that up so we can have the fall off be softer by increasing the softness amount. Accuracy is how well it's going to conform to the object. So we could have it a bit more patchy if the accuracy is turned down. And that's kind of cool, because that way we don't have to have a very fine line around everything. Having it more varied does look more interesting. And there is that rendered area, just the small render area. Just the lower section here. You can see the shadows and then the nice little dissolve there. So I'm going to go ahead and include this version of the atmosphere with the training as well. Because of the way that texture maps are set up for the terrains, and making it easier just to open up the files and not have to find any textures or anything, I do want to incorporate them. And because the major changes are to the atmosphere, you might have to just load in an atmosphere for the version rather than an entire scene. And that way, there isn't a whole bunch of extra file size allocation for the images and the textures being used, the same ones over and over for the different scene versions. So depending on the variation and how much has changed, you might have available to you just an atmosphere preset that you can load in. But if you have the scene open, loading in the atmosphere preset will match everything up.